Basic autonomous driving research.
All right, well then, thanks everybody for coming. This is Philip Hood. We had him as a guest at our place earlier this year, and he'll show us about his basic autonomous driving.
Okay. Thank you. Thank you. So I don't want to get people too excited. We're not driving on the highway or anything like that. I just have an example of I guess a sequence of subproblems that sort of existed in a sort of storyline that I just sort of tell behind this while trying to do some research for something else, a sort of a different sort of problem. And then this came out of an instance of trying to perhaps prove something else. And I thought that it's as interesting enough of a problem that perhaps could be discussed or looked at or what have you. And I've got a bunch of data here, and I present things. And obviously, I don't have I don't study robotics or anything. I kind of got to start as a sort of web programmer, programming Perl for web pages and all this sort of stuff. But then over time, have been looking at sort of other instances of issues that you can use for, you can use programming to kind of solve or what have you. So in this case, all we're doing really is we have a device, which I brought an example of, which has a sensor, right? It has a camera, and in a real-time fashion, what we're hoping to do is to take a picture, literally, with the sensor, and you can perhaps more largely write this as having many different forms of sensors, and then to, in a real-time fashion, drive the device given input from those sensors. So anyway, we have through DCPM, a web server called Perlish.org, and anyone, in theory, in the Perl community, or perhaps not even in the Perl community, could get an account. So I wanted to put some papers or whatever you want to call them there. So the web server, again, is Perlish.org. It's PTH. My name is Philip Timothy Hood, and I just put some papers there. So essentially all I'm going to do is just read through the text that I have, show you a little bit of data, and then talk about it if anyone's really kind of interested, and examine some of the subproblems that obviously that we come up to. It's an MP4 file. It just kind of shows you the coursing of this thing, this little drone by this company, Parrot, kind of coursing around a blue piece of painter's tape that I've put on the floor in my lovely apartment in Manhattan. Now, as it kind of makes its way around the circle, there's a few things that's happening, of course, but essentially, again, it's taking a picture, right? It is transmitting that picture to a laptop over a Wi-Fi connection. The device, when it starts, creates a hotspot. You read the file. There's a few ways that you could read the file, but what I discovered was that it was far more slower and more verifiable or perhaps deterministic in order to create a picture and then yank it from the device using FTP, as opposed to another thing that you could do, which is it has a video feed, so to speak a video feed, but it's really a sort of a still, it's a sequence of still JPEG images that you would get. And the problem with it in this case is that it varies. It could, in theory, do up to, I believe, 16 frames per second, but frequently did not. And under certain conditions, that frame sequence would slow down. It would go down to 12 or what have you. So my first thought, of course, was to read, while going, read the pictures and then try to drive it, perhaps very quickly. And again, I'm just urging others who are kind of interested in this problem. It looks like this is a quite interesting problem, to buy the device. It happens to be very cheap. It was chosen for its cheapness. And so without further ado, I'll just kind of read through the text. Some of this I've obviously already just repeated, but I'll repeat it again, and again, you can download more information. There's now this work was kind of primarily done last summer, and my hope was that I would have something verifiable and kind of provable, so to speak, and then I would take it to, I was traveling around Europe, and I wanted to go to the Alpine Swiss. I did go to the Alpine Swiss Perl conference and then present something there, but I just didn't have everything work. In fact, this video was shot right, like 2 days before I actually left, but I didn't have time to write it all up and do everything else. So then I was like, okay, then I'll just attend it and, kind of take it later. And so then in February, I went down to DCPM, which is really my home Perl organization, and did some things there, got some feedback, and so that's why this is dated on in January. And then based on some feedback that I got, I decided I would make just a slight handful of changes. And so there's another update to this page done just a few days ago, and I'll kind of go over that if obviously there's enough time. So I had a number of motivations. Those motivations really were, how does one determine if it is possible to come up with a sort of computational understanding of morality? And in this case, a number of people were talking about the very interesting sort of quote-unquote trolley problem. What do you do if you're a driver, you're a robot driver of a trolley, and the trolley sees a handful of different things, right, before it. It sees, and it must crash, right? I mean, something occurs and it must crash, and you've got a young baby here and 2 old people walking across the street and perhaps a dog in the middle of the street, and it must make some sort of decision. And how could you come up with some form of computational algorithm that could help it make decisions? And there are a number of groups that are now trying to produce varying papers and some knowledge on this. So I thought, okay, this is kind of like a very interesting problem. How would one begin to solve that? And while talking with someone else, I sort of flippantly said, well, it is a trivial problem to just take a device and just drive it. I mean, this is a very well-known problem. It's in fact been solved. There's varying examples of this in the 60s and elsewhere of just reading input, and driving a rover or what have you in some sort of autonomous fashion. So then they were like, well, prove it, right? I mean, if you say it's trivial, then just do it. And I said, well, sure, I'll do it, right? Okay, this is, fine. So let me just go ahead and do it. And then my sort of troubles sort of began, right? I mean, and it is, to a certain extent, it is not I wouldn't say it's trivial, but I'll present to you the things that I kind of discovered and how I kind of solved it, Obviously doing these things in real-time fashion, moving at 60 miles per hour, or more, I think would be very interesting and worth someone's time, right? I mean, Anyway, so the mirror question was raised. Can I program a working, even if trivial, autonomous Lee piloted vehicle? And so at first I thought, well, what I'll do is I'll buy one of these drones, right? I'll buy one of these little copters that kind of goes around, and in fact there's code or in Perl on CPAN that shows that it gives you the driver and all this sort of stuff. In that case, however, a lot of these devices don't have cameras, and the cameras, if they did have them, are usually not very good. And so then I thought, well, what I'll do is I'll attach a camera. Okay, so then you start to question, well, what is the weight of the camera, and what's the quality, and how are you transmitting information back and forward? These things are actually usually somewhat expensive. They're several hundreds of dollars. And for the scope of my project, I just want to do easy things. I'm not actually very interested in doing anything that's too complicated. Maybe I could make something myself, I thought then, after kind of examining the price of some of these devices. $1,000, $2,000, like, okay, no, we're not going to do that. So then I thought, well, maybe what I'll do is I'll buy a remote-controlled car from Radio Shack, and what I'll do is I'll hack then the remote-controlled device. And I think that's actually a fairly interesting way to go if someone is so inclined. But then I thought, well, then you've got to hack this thing, and then you still have to attach a camera to it and all this sort of stuff. So is this now going to cost more than $100 or $80 or whatever? And is it, with the spirit of the project, which was just to have some fun, right? Just sit down, come up with a problem, and see how you could solve it, right? In an interesting sort of way. Okay, even if trivial. Now, I did some research and I found this device. This is the 4th one of these that I've now purchased. And I would name them. You can rename the Wi-Fi hotspot. It is unencrypted with an application that you get, you download, you put it on your iPhone if you have one of those. you name the hotspot, you link on. They give you a sort of a tool that allows you to drive within the device. So I said, okay, fine. So it also has an open sort of protocol and a document that it prints out and an SDK. The SDK is a C SDK, and it has bindings from varying languages. So I said, fine, okay. And furthermore, because it's unencrypted and because there's an quote-unquote open protocol, then I can just sort of write my own little driver myself. So if I don't want to actually hack the application, I can just recreate the protocol myself. And in this case, what you do is there's some handshaking. Once you connect, you send some signals. It tells you, well, what port it's going to be reading on and reading off of. And in most cases, the work that I'm doing with, on a day-to-day basis, and I'm doing some back-end stuff, I'm doing some reading from databases, I'm printing out some HTML and things like this, collecting stuff, doing database. Never anything that kind of deals with robotics. So infrequently do I have to kind of create a server, connect, read and write to ports and all this sort of stuff. And therefore it's interesting. Right? It's like, okay, this is now a new realm of programming, and it kind of helps to stretch my knowledge base. And I like that. I mean, it's kind of interesting. You can do this with Perl. It doesn't have to be complicated. Perl, from my perspective, is a very easy language. You just try something, right? It's a great prototyping sort of thing. You just sit down and, okay, here's a problem. Let me see how I can solve it. So, of course, I thought that what would be nice is to have the entire sort of autonomous driving done on board. And I think that would be the sort of first in class. Like, let's say that there's a powerful enough CPU that's on this that you can then run a program and just kind of plug it in. But at this time, there's no really easy facility that you can do this. Now, it's open, so what you could do is you could, in theory, and others have done this, you could take the entire OS for the Parrot, and then you could begin to hack it. And then you would have to then flash the drive and all this sort of stuff, and some other people have done that. But again, I think it's sort of out of scope for the project. I just want to do easy stuff. I don't want to bend my mind and, or even burn off the device, right? It's $100, and let's say you have to do that now with your $1,000 device. Now you're out $1,000. Now, for me, I wound up having to purchase, again, this is the fourth. So in the first case, one just stopped working. In the second case, I did something, and it just kind of ran up against the corner and ran, and then finally, when I picked it up, one wheel wouldn't work. It all happened to happen fairly quickly, so then I was able to take it back to the store, and I kind of complained. I said, whatever. Didn't tell them I was doing basic autonomous driving research, right? Didn't tell them that, but they said fine, and then they gave me another one, and okay, fine. This one happens to be the, was a year past, and I hadn't taken a bunch of pictures and so forth, and the device just didn't work. And I was like, what is this? So anyway, so I want to just do easy stuff. So then I found this little guy, and in fact, the Parrot company, it's a French company, produces a handful of very interesting sort of things, I think, all having this sort of open protocol and so forth. Some allow you to drive with, using GPS points and all that sort of stuff. So anyway, just to sort of jump down, what happens is it's producing 640 by 480 JPEGs, and again, you take a picture, right, and then you take a look at what's in your picture, and you make some decision as to whether or not you'll go left or right, and perhaps whether or not you'll go quickly left or quickly right, or will you go maybe not as much, maybe only 10 degrees, 15 degrees, or what have you. In my case, I just boiled it down to either I'll go straight, left, or right, and I use constants for that. All right? Now, you start to get into a whole sequence of problems with this, which is that if you're moving too quickly, it turns out that the angle of the device, obviously, there's like a cone, right, that the light is traveling in, and what will happen is, in this case, it's about, I think, 12 inches, or perhaps a foot, maybe only 8, that the light cone falls over a horizon. So in other words, you don't see, with this camera angle, you do not see anything that's closer to you than as close as 8 inches, I think. So if you're moving very quickly, unless you have a sharp right turn, as you see in this picture, then if you don't make your determination as to whether or not you'll turn before, right? In other words, if you're only moving 5 inches ahead, then it's really the next frame that you really want to make your decision off of. Okay, but if you've moved 5 inches ahead, because in this case, as you can see, I'm actually trying to go straight, right? But I mean, the line that's underneath me is straight, but if I go another 5 inches, then my next picture won't actually have any blue path ahead of me. So that's a sort of problem. So then I thought, well, maybe one way to solve it, and in other devices that Perl sells, it allows you to change the angle of the camera. Fine. So mine doesn't do this. Mine is only $100. So what I was like, okay, well, what I'll do is I'll just put a little camera. So I got a bicycle helmet I'm sorry, not camera, but a mirror. So I'll just put a little bicycle mirror there, and then I'll just kind of maybe try to focus now on that, and that will get me directly underneath the device. And then I said, this is dumb, you know, just whatever. I mean, I don't have to do it that way. But I wanted to, you know, again, now we're discussing the sequence of problems that kind of come up with this particular approach, and maybe someone else can solve it in some other way. So what I do is, it's 440 by 480, but as you can see, if you look at this, is that a little short of half of the image shows a horizon. So I don't really care about anything that's over the 200th pixel line if my orientation is from the bottom left corner, right? So I don't care anything about it. So I can just snip it off, right? So okay, fine. So then I snip it off. Now we say, well, okay, well, how do we then get the blue, right? Now there are all these different ways that you can do blue. Now I'm JPEG, and the data is stored as RGB values. Okay, we've got only 5 minutes. So I've only got RGB values. So what I'll do is I'll just add some really basic filter. Well, what is blue, of course? Well, that's, I think, somehow complicated if you're in an RGB color space. So now you say, well, okay, well, how do we then calculate a new color space? Turns out OpenCV, which is the underlying library that I'm using here, has some conversions from RGB to OpenCV. So, okay, fine. So now you do some conversion to some other color space. Okay, so now you got to go out and study what different color spaces are. So there's HSV, somewhat complicated, but I just filter out. I say, well, fine. If the hue is between so-and-so of a value, and if the saturation is of a so-and-so value, and if the vibrance is of a so-and-so value, then, okay, so then we'll say we're blue. Now, it turns out that what's happening is the camera is sensitive in varying areas. So, and things that reflect will reflect and present itself to the camera as a certain color. So as you can see, kind of like in the middle right of this image, there's a flash of light, perhaps coming from the sun, at a certain time. So the flare around that now presents itself as blue. Turns out that the vibrance level is fairly high on that, so you can now begin to chop. But what happens is, if you're doing this work at like 12 o'clock in the afternoon, it's one thing, but if you start doing it at like 8 o'clock, it's one thing. And if you're using a sodium lamp or whatever, then your colors will present themselves in such and such a way. So now you're saying, well, okay, actually what is blue is not really blue. I mean, maybe it's actually something else, right? And you've got these fixed values that are saying, okay, well, I'm hard-coded into this, but now it doesn't really do that. So, okay, then I shrink it and do some other shrinking, and then I say, okay, well, how am I going to determine which way I'm going to go? So what I say, well, okay, well, what I'll do is I'll just add some sort of like scaling, which says that, okay, if you fall in this area, then we'll multiply you by a certain amount, and then given the weight of what that is, I'll scan left and forward, something just simple. And if you're in the front or you're in the middle, then that's where we'll wait. But let's say that I've got blue in this top right region or top left region. Well, then I don't really care about that. And so, and in this fashion, I can say, well, let's go to the middle because this thing is really in the middle. Just some algorithm I just grabbed, right? Who knows? I mean, you play with it and see what happens, right? And here's a cute picture of, like the device is kind of cool. And then there were some other things that I thought, was kind of cool, which I won't really go into now. But at the meeting, some people were really upset at the fact that, when you take a look at this is what I grabbed with my filter based on that image. So they were like, well, maybe you can do something else. You can come up with some sort of some sort of like AI way that you can train it, right? You can take it on a run first, and then it would, kind of like take the images, maybe do some kind of, untrained, unsupervised grouping of the colors, and then you can say, well, okay, you can, APR, I know that this is, say, blue, as an example. So I kind of looked at that, and I said, okay, fine, let's take a look at some other color spaces. And it turns out that lab is pretty good. And there's a conversion in OpenCV, and basically it's just two poles, right, A and B, and then an L value. Okay, so I think we're done. And this now shows the filter. And finally, what I do is I put a place, I make a page, which we will not maybe be able to get. Okay, fine, so it's going to load. So now this is another example showing lab filtering. And then I take the points, I make Boolean points out of them, and then I just display them. And then you can kind of see, the before and after. And there's one that's kind of interesting. Oh, it looks like I got some. You can kind of see these little star-type speckles off on the side. Again, it's to show that even now with this other form of filtering, you're still getting all these varying artifacts that you might still have to deal with. But you could say, well, what is the largest thing in my picture, right? I mean, you could begin to apply these things, but at the same time, you kind of want to do it fairly quickly, right? You want to do it depending upon how many frames do you want to take, and you want to drive this thing. If you want to do 30 frames per second, in my case, I'm doing just about 1 frame per second, 2 frames per second. I can do all the processing in about, with my computer, like a tenth of a second, maybe a 15th, 0.15 of a second or something. I can get it to run. There's some other interesting ones. As I loop around the corner, I didn't take a picture of the entire thing here, but I've got basically a semicircle, and you're just seeing cropped images. And as you go around the corner, you see that in different frames of light, the blue begins to change, of course, and the filtering is not working again as good, especially as you get around this side of the corner. And you can see in this 24th image, you're getting less and less information, and then finally it kind of comes back again. And these are all depending upon the reflections and so forth. And then finally, if you go to the web page again, you can kind of look at everything. There's some code, you can read it. It's pretty basic code. You can play with it. You can come up with your own, say you don't like my ideas. What I will say is that finally, spending time sort of reverse engineering the protocol was actually very interesting, because what I wound up having to do in order to have it take pictures is instead of getting the video feed, which was a glut of information, the protocol also requires that you send signals to with a count and all this sort of stuff to the device, and if you don't do it at a certain amount of time, then the device will begin to shut off, which is like yet another problem. When the device gets hotter, then it starts to take pictures that are sort of slower. So if you don't have everything sort of regulated appropriately, then you begin to have problems. So now you have to do some sort of multi-threaded operation, which is interesting, I begin to think. Finally, in order to, again, you send a sequence of packets in a format, so now you're into pack world, right, which is interesting again. And in order to send, and when you're trying to discover the protocol, you can read it, but it doesn't really say, well, what's left and what's right. So you kind of have to discover this by osmosis. And for the device to discover how I had to take just a still frame of a picture, the application in the iPhone has a little button, it takes a picture. So in that case, what you can do is you can connect to your device if you have a Mac, and then you can use something like Wireshark, and then basically, given what you know, you can begin to filter out the packets until you determine that the one packet that you don't know is probably the one that is saying, okay, well, now we're taking pictures. So now you can, having reverse engineered this, you can then route this into your program and then send it and see if, in fact, a picture is being taken. And that's it. So I will again show you the lovely coursing of the little drone around its merry way. It's kind of interesting because you see it'll bounce to the left, it'll bounce to the right, it'll go forward. I tried some green color. I was like, maybe I'll just do different colors. So it turns out that you can see that the device has green lights, right? So those green lights on the floor now reflect green. So if you have something that's green, now you have to figure out how to filter out green also. So now I've got like two problems. First, the flares from the light are blue, but now the reflection from the lights are now green. So then my girlfriend was like, well, why don't you use red or use yellow or whatever? But okay, fine. So there it is, and it was really fun. And you could do it with, with a few languages, but Perl you could do it with as well. And I'll take some questions. And sorry for keeping you over.
So if the processing is happening at
0.15, that's right, yes. So I read the image, I convert it from RGB to lab. I then throw out information that I don't want, so then there's a filter. And then I do some sort of like calculation to determine, and then I do a final pass to see who's got, am I going left or right? And I can do all that in 0.15. I mean, that.
So are you issuing a command every 0.15?
Right, so I am not issuing, no, I'm on a loop, a VT alarmed loop that will run every twice a second, I think, is in this version. Right. So I get the information and I make my determination, and now I've got 0.2 seconds to just sit on my butt basically, and then I issue another command, having determined it. So
you could already be smoother.
in theory, yeah, in theory. I mean, this worked, and it was like, I spent a lot of time. I mean, it looks great as far as I'm concerned. But yeah, in theory, you could be smoother. You could use multiple computers, right? You can have one working, two working. You could do all sort of stuff. You could use GPUs to make that determination quickly. You could, there are all sort of things that in theory you could do. But it's okay. Also, I'm fixed, right? So I'm moving left and right at a fixed, or going straight at a fixed place. You could make a determination to, instead of going a fix, you could refine it as well. And I'm going to leave that up to the community, right? It's like, yeah, I could beat you, Phil, right? I love it. I want to see it. Yeah, it's kind of cool. Well, so no, because blue for RGB is like some of red is blue and some of blue is blue and some, right? Yeah, I find it kind of weird to kind of. Go ahead. Yeah. You could do that. I mean. So by looking for edges, normally I think what these guys do is they take the entire image and then they do they calculate a gradient and then they recalculate it and all this sort of stuff, and then they determine where things are edges, but edges of what? In my case, and that's fine. And I'm not saying that I'm right or wrong. I'm not saying that. Mm-hmm. Yeah, I agree. I mean, beat me. Just beat me. Just you buy the device. It's $100 and say, Phil, you don't know what you're doing. We'll come up with a course. Who goes fastest on the course? And we'll, and then we'll meet next year. Yeah, next one we'll go for it. Right. Sounds like fighting words to me. It sounds like fighting words. I agree. Yeah, I agree. I agree that there's algorithms that were from the 60s. I think the A-star algorithm was created to make this path, right? So these are all done issues. And as I said, as I was sitting around, I was like, just as you're saying, I said, this is trivial. This is, I was like, this is a trivial problem to solve. And what I'm saying is, okay, so now you've got hardware, you've got, a bunch of sub. Fine. I agree. But in this case, I didn't want to, I'm not arguing with you here, but in my case, I just wanted to solve it myself using common sort of stuff without reading their stuff. I didn't download I looked at the protocol and all this sort of stuff, but I wasn't, the goal was to figure out if I too could do it. Can I do it? And it's not, and I found it to be fairly tough. I mean, in a certain way, it was because of the way the device was, right? And the device, it wasn't like it came, with a manual for this, the thing that I was trying to do. So there was like times when things wouldn't work. And then I was trying to figure out, well, why that was. And, it's a sort of secret, sort of hidden thing that if you do not send signals to the device at a certain amount of time, then the camera feed would shut off. So at a certain point, I was, slowing down, and then my camera would just turn off. And that's when I discovered that, in fact, I could just turn off the camera and take still images and still be able to do this pretty good. But that was, at a certain time, that was like a big problem. I was like, what's cost me like a week or 2 weeks of trying to figure out, what was going on. And there are all these little moving parts. Now, I'm not saying that this is the best device for this. I'm just saying it was cheap, and I just chose it and, said, okay, now I'm going to sit down and solve this problem. I'm going to just set some confines and just have some fun, separate from my work and anything else that I'm doing. What's that? Right, yeah, it's cool. This little device is cool. This one actually is a newer version of it. It has a recorder in it. That's right, and it's problematic. The tail will bend back and pop up, but it also causes friction. So if you have, if you're not moving fast enough, like say you want to move slowly, and you can kind of see here, I just kind of threw some tape down. Tape has a little bit of a ridge. If you're not moving fast enough, then you won't be able to overcome the little ridge. Now, obviously, why do you have ridges? But, it's yet another class of problem. Okay, so thank you so much.